prednášky na aspektu orientovaného UI softwareu. I'm going to have this in English again. Okay, so, but any questions or remarks or whatever you would like to say, you might say it in Slovak. Just check this camera. There was some sound, something, but I think, yeah, it's working. Takže akékoľvek otázky alebo čokoľvek k tomu, čo sme mali doteraz, did you manage to try any code? Do you have Eclipse installed? Aspect.J? This is essential. There is a part of your project that you should develop in Aspect.J, not a very extensive part, but you should kind of get a little bit comfortable with Aspect.J. It might help you to think of aspect-oriented things, not just in other programming languages, but also in other approaches as well as such. Do you need me to explain anything we talked about last time? Do you need to return to anything? I will be repeating some things through some new code that I will be showing. So we might get to some things that you would like to hear again. Anyway, but is there anything special you would like me to explain? How about projects? Any questions regarding topics or so? Everything's fine with Yahoo. If you have any questions regarding projects, individual questions, we can deal with them after the lecture. And today's lecture is about aspect-oriented design patterns, as I advertised last time. So you all know, you know about design patterns. Some design patterns like that you dealt with so far, apart from Devo. So I guess most of you saw observer, visitors, but you might think of design patterns in the most, like the mainstream way to think about them is like already used solutions, and you do not think very much about the problem behind that you're solving. It's actually generating the need for that solution, at least, to say so, or maybe even a part of that solution, or the solution itself, it actually begs for it. And behind all patterns there is a conflict or contradicting forces. We'll start with a problem. It's best to go with patterns. It's best to go by example. And then I will generalize some things about patterns, maybe even beyond aspect-oriented programming or beyond the patterns that I will be showing. So for now, it's a kind of a little bit of mystification. I'm not pretending it is not, so I'm using a notion that I did not define, and I do not want to define it at the moment. Let's forget about patterns and let's check out this problem. what would you do if the task would be to reorder method calls according to their arguments without writing that code? So you have method calls. I will show some examples. So this is a generic problem. Those methods represent whatever you might think of might be useful to reorder some transactions, and maybe the arguments their arguments are denote their priority or the date by which they need to be executed, performed. So there are different possibilities, whatever you can imagine or want to imagine, but in a sense you have some method calls like here. So again, this is not much of object orientation here. We must have a class because Java requires this. So you have a class, and then you have the main method and some method calls. This new C dot method call means that first you create an object. You must create an object. If M would be a static method, you wouldn't have to create an object, obviously. But I made it an instance method, and it means that I have to create an object of C. And what I'm doing here, I'm creating new objects each time I call M. I might have created one, and then had these calls like that. But I did it this way. It doesn't really matter for the sake of this example. What matters is that there is really some argument. It's not a date. It's a simple integer number. And you can see that I'm calling this 4, 7, 3, 5, 1. Well, this might happen in some kind of a loop or with some if statements, and that argument might be coming from the outside world, depending on some things maybe that are out of your control, that actually are set by the user. So you can't know what they will do or what kind of argument they will provide. So in a sense, you would be having anyway something like this, repeated calls to M with different arguments, and imagining that M might take some time and resources to be executed or whatever is the reason. So currently it does not. It executes like that. It's short. It's nothing. But if that would be a case, that you might want to reorder these calls so that the one with the greatest priority would be executed first. So, what would you do? You can talk to each other. This is a difficult task. Maybe we will come to some idea. One thing might be obvious what you need to do first, and then you might think, I'm not asking you to give me the code in aspect J that resolves this. But just to express what do you need to do in plain English, Slovak, or we might accept also some other languages. Not exactly French. Okay, any ideas? What do you need to do first without any doubt? I mean, you want to reorder these calls, so if you want to do anything with that call, you must capture that call. And the call point cut is well known to you, so you know that this is possible. So we can capture these calls, each one of them, and we can say what will happen before them, after them. And one more thing, we can hold that call. So we have before, after, and around kinds of advice. And it seems that before won't help, after won't help. So we need to, if we want to reorder the calls, we somehow must prevent this M4 from executing until M1 is executed. So we must capture it and hold it for some time until M1 is executed. But who will say that M1 needs to be executed? So if you capture this and wait until we come here, but then we hold this, then we must return. We must somehow, we're coming to the idea that what we need to do here, we must somehow capture these calls and then reorder them. So make it static for us. Like now it's dynamic. We have these calls one by one coming and so on, and we don't know what to do. And we say, okay, no, stop. We have this sequence of calls. I have this sequence of calls. You know how method calls or procedure calls operate. There is a call stack, so-called call stack. Oh, you don't know that. You must know that. Stack Overflow comes from that. And that actually the discussion group is actually named by this peculiar problem of having Stack Overflow. When do you get Stack Overflow program?
Comments? Too much calling of the functions.
And that happens usually when you have recursion and it's infinite. So you don't have you're not stopping it, and you get too many calls because the memory is limited for this and so on, and you reach the limit and you get Stack Overflow. So method calls are put on stack because you have to return to them later, because you have one method, then or operation in general, procedure, and this procedure calls another one, and this calls another one, and then another one, and so on. And then when this one finishes, what has to happen? You have to return back to the context of that call and back and so on. So stack is exactly the structure that enables you to do this. So you're putting all these calls on the stack, and then you're looking. The stack is just a structure where you can see just topmost element, and then you can deal with it, or when you put it away, pop it as that is being said. You pop that element. You can see the one underlying. Stack might sound as some kind of strictly computer science invented technical notion, but it is actually of cultural origin. It means just when you have hey, seno, slano, čokolek také, hey, stop in Slovak, stop. This is a stack. So it's quite natural origin of this notion, and we adopted it as a stack. Even in Slovak, we use it in all other languages. Again, try to turn off my screensaver. I don't actually know how that time is shortened by some update or something like that. So we have these calls. So I'm going to show you. So after this analysis, we can't do much, but study aspect J, and I studied it, and I know exactly what can be done, and I'm going to show you the solution. But you would come to it somehow when if you would really get through what aspect J enables. Again, I'll mention the notion of patterns. This is kind of characteristic for patterns or idioms, not idiots, but idioms, similar sort of characteristic expressions for a particular language, which are not easily understandable or not understandable at all by just knowing the elements they consist of. So you have kind of get used to that. For artificial languages like programming languages, this is not that mysterious, but still they are so complex that you to find your way out with these things, it takes quite a time. So you are considered to be fluent in that programming, in a particular programming language when you know these idioms and you can you use them without huge effort. So you're not speaking Java or C, but you're writing code and you know these tricks. And patterns are much about such things. So there's always some kind of a bit of surprise. And it's visible in for design patterns when they are implemented, it's visible in code. So here we have this kind of surprise. This is the whole thing actually. So it's not long, but let's get from the beginning. The beginning is that we, as I said, need to capture the calls. And here I'm really capturing these calls, and I'm capturing the arguments. You remember that this is actually an intersection of these two sets of join points. So we might be tempted to read it, okay, you will capture these calls and capture the arguments, okay. Their arguments, but it is not quite so, because this captures all the join points that integer arguments, and this captures all the calls to the M method of the C class, and the intersection of these are actually again is the same. It is called because all of them have the integer argument, and so that doesn't change anything. But this is a kind of context capturing point cut. So not all point cuts are capable of capturing context, but the arguments point cut is part of that. So we are capturing the actual value of the argument, and that's what we need. We need this to reorder the calls. So when we capture a call, we have it in the proceed statement. So if we run proceed, we will let it go, let it execute. We don't want that. We want to keep this. But the program is continuing. So what can we do? So you must remember, this is not a thing directly related to aspect-oriented programming, and not that much maybe to the basics of object-oriented programming, but to Java. You might remember that you can create a class. Well, I could have this I could name this class, but I don't need a name because I need just one instance of that class. I actually need to wrap my call in an object. It's the only way that I can keep it. When I have an object, I can put it in some structure, save it for later, and get back to it whenever I want, if I have an object. So now at the moment I have the implementation of the method that I want to be saved for later, and it's being called in the proceed construct. So what I do here is that I create an object with only one method, and this object is being created based on the prescribed interface. So things get nasty a little bit with this. So there is an interface called runnable, but it's nothing. This interface is just prescribes one. Very good. So interface. If you look into Java API, you will see that the interface runnable looks like this. Void run. There's nothing there. It's just a prescription upon which we can rely onto which we can rely on, because once you say that you implement this interface, as I'm saying here, by this construction, which looks a little bit strange, but it is just as I'm creating a new object based on runnable. And when I create something based on an interface, I must follow what it prescribes. So I implement this method run, and my implementation of this method run is simply this proceed that I captured. this is the twist. This is the trick. So when I have this object, the things are just plain Java. So what I did, I created, I found this priority queue to be an interesting, ready-to-use structure that can help me reordering calls. I don't have to implement this myself, really. So I just put my call, but my call is actually in this C now. This C is the object that I created, and I put the argument as well because it will be used for reordering this priority queue. And when I want to execute calls, when do I want to execute calls? This is another thing. So now I have them on this queue, but I need to execute them at one moment. And for me, it's the end of the main method. So when we finish with all of them, capturing all of them, this is the responsible moment that I want them to be executed. So after this statement that I'm printing out AAA, just as a raw message, just to be sure that this is being given. So now when I execute this code, and for this I didn't explain, I just captured the call, not call, but there is no call to the main method that I can capture. It's not exposed, it is not capturable. So I can't really put here, if you try, you would capture nothing. So this is one point where we need to use the execution point. So when I execute this code, it's like this. So clearly it's not 47351, but and the order is nice. 1, 3, 4, 5, 7. It works. Not a surprise. So the thing to take away is that you really can deal with proceed as a method body that you can use to construct something with it. So you don't have to execute it immediately. And this can be used in various contexts. I named some possible examples. Maybe you have some ideas, and you will encounter similar problems. And then you will come to this way of resolving this problem, of actually that is actually that joint point has to be transferred to another context for execution, but without transferring the corresponding code. So the capture joint point, in my case, it's the method call. It did not have to be exactly a method call. It could be just any joint point. So you capture it because that joint point is a final prescription of what is going to be done next. And the problem that you're solving is that this joint point has to be transferred to another context for the execution, but without messing up the code that contains this joint point. So from the outside. That's what we did. So this is kind of, when you look at this problem, so this part of construction, so this is a conflict of contradicting forces. I want to do this, but at the same time I want to I want to do it. I want some other thing to hold, or I want I don't want to, I don't know, do something else. So, and it sometimes often it looks like, oh, this can't be solved. There's nothing to do about it. So one of these patterns came to us from building architecture, from the architect named Christopher Alexander, and they did not represent the mainstream of the architecture. I think I could use this one as a switch. I think it's not that important to be recorded. I want more camera, but there is a pattern for building architecture, or actually pattern. The problem in the living space, especially in the living rooms, where you have typically a family, friends, or some people, simply some guests, gathering and exchanging thoughts, talking, and so on. But often it happens that, as now, so there is some central thing happening here, which happens to be my lecture, but you feel a desperate need to chat about something, and not just writing messages, but to talk to each other a little bit. You could go out and be not disturbed and not disturbing the lecture, and talk to each other. But you don't want to miss what's happening here in a way. So I want to be connected to the central activity, but still have a little bit of your private conversation. And this happens also like in the living rooms, and for this you need to have an adequate space. So there's a tension. You want to be part of the central activity, but you want to have some privacy. Again, but, so conflict of contradicting forces. This tension generates an adequate space for this, if you allow for this. And it's called alcoves. And it looks like this. So you have this room. You can have several alcoves. You can have maybe like something like this. So this is the central activity is happening here around some table. But you might have a smaller tables or just a sitting place here, and another one here, and people can sit. It's usually best if it's for two people. Sometimes you use it alone, so you want to do some things on your own, but still listen to the central, be connected somehow to the central activity. So they can talk to you, or you can talk to them, or whatever, for whatever reason. This is called alcoves. And that's how it goes with patterns. I'm not going to talk very much about how then you can actually you are putting alcoves within a house. So there is a pattern again. There are several patterns that resolve the problems of your needs for a house. So you have particular needs depending on whether you're alone, or there are two people, or several friends that need to share a house, or are you a small family, and such things. Or do you need to build a hospital? Do you need to build some other building in churches or whatever? Whatever is the culture defines that is necessary, and the different spaces are needed to enable life. So, in a sense, patterns enable life. That's a little bit of mystery behind patterns, but we are not going here at this moment into details about patterns, about the mystery of patterns, mystical side of patterns. We are going to take a look at further technical details of further patterns and technical details that correspond to them in aspect-oriented software development, aspect-oriented programming. But before that, have a look at this. So I tried to generalize a little bit. It's difficult to generalize patterns. It's difficult to build really write a really sufficiently or completely general code that you can use in any context. So I have this pattern and I implemented it and I can reuse it. So I take it whenever I need it and just use that code. It always has to be adapted to the context. But you can and things built out of pre-built constructs, pre-built building blocks. Like imagine you want to and not so long time ago, but even now these big buildings like with flats and so on for many people, many floors are built. Might not be fully corresponding to what is required, but this is kind of a more economic way to have some living space for many people. But not too long time ago, these older buildings from socialist era, in order to build them more quickly, they actually pre-built whole parts of the buildings and just put them one on top of each other and put them together. That's not how you deal with patterns. That's not how you respond to the needs of people. That's not how you put things in the context of the given space. So that you suddenly have some building, somebody made up the plan for that building without even going to the spot to see how it actually looks like. Nevertheless, if you want to express somehow, this is always a struggle. If you want to express somehow what the essence of a pattern is, you have to use some means. And one of them is to try to put together some piece of a generic code. And it's good enough if it's just indicated like this, so there is no clear point up there. So we're capturing something. I'm not relying very much on, I'm not saying that the whole point cut is the essence of this pattern. We are capturing some joint points. It is essential to do it using the around advice, because otherwise we won't have proceed. And it is essential to create, to wrap up this proceed in an object. So this is indicated here. I'm compromising the genericity of this representation by showing a kind of quite specific implementation here. So it's kind of an example. And here also I'm mentioning some cube. It need not be a cube. So I'm putting this away And what happens, or actually invoke, what did I want? I wanted to say that actually I have this invoke structure or whatever. It's a little bit strange here. There should be some invocation of this. I'm not. What I'm saying here is that I'm putting this worker on some queue clearly, but I'm not dealing very much with what happens next. It's not essential for this pattern. So this is the essential thing that I'm capturing this thing and putting it away. It's essential to use the around twice, and when you see this code, you get a glimpse of what you need to do. And patterns always have some name, or should have some name that reminds you of the essence. And this one is named worker object creation. Another name by which it is known, so there often in parallel exist different names like synonyms for the patterns. Worker object creation or proceed object. Proceed object immediately brings you to proceed in your mind. Worker object creation might be like, okay, I can create a worker object, an object that does something, and this might bring you to this runnable interface, which is a standardized way. Whenever you have many frameworks, why does this interface exist? You could create an interface named XYZ, and with method blah 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 or whatever. But the problem is that no one would know about this. This one is published. It's a part of the Java API framework, and many parts of Java API framework expect objects of this kind. And many other frameworks expect objects of this kind, and then what they know is that when they get an object of this kind that implements this runnable interface, they can run it. There is something there that can be executed, and actually it's the only thing that is there. Any questions about worker object creation or whatever? No. Let's get to another problem. This one is more not that generalized. So imagine an organization, and there is what's not said here is that there is a system, an information system in that organization that's being used to record the tasks that the workers in that organization perform. And some kind of task management system. And what happens is that, or apart from the usual activity where you have tasks and you can execute them, and this is being also recorded and so on, the thing is that you can propagate these tasks to some other workers because you can't perform them. And you don't want to do this with the tasks issued by unwanted authority. So it's a big organization. And you can imagine, maybe very distributed, that some part of it gets compromised somehow, infiltrated by some other organization that, or somehow compromised, and you want to exclude this part. And your system is implemented in this way that the basic things are there, but you want to add this functionality. So your system is not ready. It looks like something. It looks like this. Sense. It's not ready for this change. So it's not just that you don't want to mess with that code. It's already there. But actually, where should I start? It's a bit, there's a bit more things there. So I've taken this as a simulation. So let's start with the employee. So you have employees modeled in your system like this. They have some capability, and they are part of maybe you could say project. But it is a simulation, so it will simulate what happens really, because we don't have these people who issue this and solve these tasks. So what an employee or a worker, as I've named it, can do is to solve a task or try solving a task, and if it can, if the employee cannot solve the task, it will yield task, and it means propagate it to another employee, which is connected to this one. And this is just a message that brings out what has happened. So not in particular, but particularly. So here we have this famous concept of authority that I mentioned. So the authority actually starts by issuing a task to some employee. And when the employee gets the task, the employee is forced to take the task. So take the task. And in order to make this a little bit funnier, I introduced random capabilities. So the capability of the employee is not known. It's random, so we don't know what will happen. And then based on that capability, because in reality it would be that, okay, I received the task, and I'm looking at the task, and I'm considering my capabilities. So, okay, am I able to resolve this task, or I'm not able to resolve it? So one thing is, if I'm not able, so I have zero capability, I will give it away. So yield task. If I think I'm able, I'm not sure, I will try. And if I'm sure I know, and then I solve it. If I try solving it, then again I will I'll be trying, and then I will be reconsidering my capabilities. And if my capability actually is not what do you say here. I will reconsider my capability and eventually yield the task. Maybe a little bit mixed up. It doesn't really matter, but the essential thing is that in the end, many things will end up with yielding tasks. And the task that I received, I might have received it by a colleague employee, and he or she received it from another colleague, and so on. And I don't know here, anywhere here in this code, I don't see the issuing of authority. This information about the issuing of authority is not transferred to me. I don't have this information. I would have to ask people about this chain. And this issuing authority, which has its ID, may be the one that became compromised and that we want to ignore. So there is this information somewhere at the beginning of this chain. When the task was issued, we knew what authority issued the task. But this information is lost by the time it reaches the employee that executes the task. So the problem is, how can we connect this all together so that when we run a simulation like this, so we have authority 1, 2, and 13, and we say that 13 is the one that is out of the game. So it starts off. How can we, and maybe we don't have this information at the beginning here, so we can put out this code input from the simulation, but it's just that it might happen over time that at random I could have this here, another generator of random numbers, but it would take too long to get to the particular authority, and it might not happen each time. So it's just static here. So in reality, these authorities would be issuing these tasks on their own, so they will behave in a way that is not known to us. We don't know in an unexpected way, so we don't know when this will happen. And to make this less complex, I just put it in a static way. So the question is now, how can we manage this? How can we prevent such authority, or not prevent the authority, but prevent we don't actually want to prevent the authority from, and we might not have this ability, maybe not, or legally might not do this, but we can say to our employees not to execute the tasks from the given authority. But they don't have this information. What's the problem when you think of it? Think of two spaces. This is one space where we have this information but we don't have tasks. And then we have another space where we have tasks but we don't have this information on the authority. So like we have to interconnect two contexts. You could do it in a more simple way without expressing this as separate point cuts, but it pays off for the sake of readability, comprehensibility. So sometimes you write a little bit of longer code in order to make it understandable and more maintainable. So don't try to squeeze everything in a shortest expression that you can. And the same way here. So if we think of two spaces, one space with which we need to deal, where we can capture this authority, is issuing tasks. So the authority issues tasks like this. So there's only one method. So this is the place. So this is just what we need to do is to capture execution of this method. We could capture calls also if we want to do this in a context, but it's just that in general we want, whenever the task is being issued by an authority, we want to capture this and this moment. We are not too much interested in this execution. We don't want to prevent it. We don't want to do anything with this at the moment. We are interested in the authority, in this information that is going to be lost. So we want to hold this. And we can do this by another context capturing point cut, which is called this. This point cut captures the currently all the joint points in the currently executed object, or the object that has control. So you could use this also without this, so you could delete this execution, and you would see it if you would print out this joint point information. You would see what, and you might have done this with the point cuts that I've given you last time. There was an example with this. Similar to within. The within point cut captures the joint points in the lexical space, in what's written there. So it follows just the lexical space of a class. Within code follows the lexical space of the method, or the text of the method, program code of the method. But this works dynamically. And there is a little bit of difference because some things are not, they are in code, but they're being executed a little bit different. It's connected to polymorphism and such things. But anyway, we are capturing here, this not for the sake to capture all kinds of joint points there, and this is a typical use of this point cut to capture the context. We will capture the authority object. And then there's another point cut. This is the different space that we are talking about, propagating tasks, which actually captures the moment when someone yields a task. And why? Because we want really to prevent this if it is being issued by an unwanted authority. And this information, which authority is unwanted, might come as some parameter somehow at any moment. It might change. It might be like a list of unwanted authorities somewhere in some database, and you should have to read this information from time to time, or at the moment that you want to judge whether the task has to be or can be yielded or not. But for the sake of simplicity, I put this as a static information here. So it's not quite static because it's an instance attribute, but it's a kind of a firm information. It's not something that comes from the outside world. What I said, it's the authority number 13. And here, it's not actually important very much for us, but what is important is that we want to capture this moment of yielding the task, and we want also to know which employee is performing this and which task we deal with. Maybe for the sake of reporting or something like that. So again, this is a combination, and often you will see this typical combination of this and args and so on. These are context capture appointments. And then what we one more thing is here that you haven't encountered yet, maybe, that I can create my own point cards. So I'm naming them, and when I do this, I can say what kind of arguments do they have. This follows the need of using them, because when I define my point card, I'm doing nothing actually. Nothing will happen about it until I use that point card. And I can create whatever kind of or name whatever combinations of point cards I want, like this. So create my own point cards and then use them and combine them again. So now I don't have to create a long expression with this and this, but I will rely on these two to me now meaningful elements that I can combine, and I'm combining them in an untrivial way. Because on one side, the part which is trivial, the other one is not trivial, so this is the trivial thing. So sure, I want to get to the authority, so it's simple. So I'm reusing this point card, where I capture the authority. But I want to do this when the tasks are so this propagating actually this this not issuing task authority but propagating tasks. So propagating tasks at the moment when the tasks are propagated is a simple thing. So I'm just using this point in this place, and I don't want to capture all such events or joint points. Better said, I want to capture only those that are within. And now this is a trick. Within this call to issue task, but not exactly just within this call, but also within the calls that are that happen inside, and within the calls that happen inside of those calls and so forth. So I want to deal with the whole control flow, and that's why I need to use this control flow point card and the control flow point card of this point card that I created. What will happen is that I will have, and I will I have the authority, I have the employee, and I have the task. And now when I capture all this, I can let things go, or I can hold them because the authority is compromised. That's the whole thing. So let's see how it works. So of course, the first two are fine, and the third is bad. So we'll see. It will be always a little bit different because of the numbers. So employee tries to solve task 5. Employee yields task 5, 4, and so on. And here we have employee 4 refuses to propagate task 99 because it is issued by 13. I could have here maybe the information to issue these tasks, but I did not do this. I did only for the authority 13. And of course, when you execute this the other time, all this steps. It's different, but it happens because we always have this last thing that's being performed is from authority 13, and this is being captured and dealt with. So the first two go fine, whatever they are, and this one, the 13, authority 13 is prevented from making the employees execute these tasks. A little bit more complicated code, and you need to create this in your context, and it looks in a more general way expressed. It looks like this. So you have this caller space and callee space, and you want to connect this, well, I reversed this there, but you want to connect this caller space with the callee space. And the caller space, you want to take it whole because of that you use control flow. And when you do this, you typically use this around point cut, but this is not the access. You might be not really preventing things. You might be adding some information. You might not be wanting to stop anything or adapt anything. You might be just monitoring some things. But the complexity is in the pointers. Whereas in the previous pattern, the complexity was in the advice part. Yeah, because there was the trick. The trick here is with point cuts. How you think of point cuts? It's not that you can't build one point cut just out of the pocket, because you might know all these things and put things all together, but it's good to when you have this kind of problem, you recognize this is a problem of interconnecting the caller and callee space, and you say, oh yes, there was a system how to approach this, and this system is this pattern, and looking at this code might give you an instant insight on what you need to do, and you will have to look at your example, your methods, your variables or attributes, your situation, and express this in terms of that. But still, you will get the idea. Yet better to remember what you're actually doing, and when you could use this is again expressed by conflict or contradictory forces like this. The calling object should be known within the context of the method being called, but without transferring it as a parameter. I'm not saying that these conflicts or contradicting forces or this particular wording that that I'm showing to you is the only viable one, only right one. You can express this in many similar ways. You can reverse these expressions most of all, so what's last will become first, and it's legitimate. So it is possible to express this in many different ways, using many different words, but the essence will be the same. There will always be this tension, this conflict that you're trying to balance. Do you have any questions? Do we need to go back to that code that I've shown to you? It's difficult to get capture all things, get all the details just from watching some pieces of code shown to you. Of course, it's not how you learn these things or really understand these things. You need to try this. So I'm urging you to try the examples. All the examples that I'm showing to you are available to you, completely implemented, and they can be executed. You can change them, play with them a little bit, just see how it goes for yourself. Or you can even be tempted to implement this in a different context. Or you might even come, by playing with them, you might come to maybe some peculiar situations, and then in the next lecture or in the lab, you can discuss that. So that would be also a nice result. Do we need to go back to this mode? You don't want the lecture to be too long or to exceed the time, so let's go to one more. I have one more aspect-oriented design pattern, and it is related to this, or will be applied to this problem. Let's imagine, well, we had this situation of this. Still, I think they did not manage to get our server or servers. I don't know very much how exactly, and this was set up in one way, and then transferring to the cloud system that was installed some 10 years ago or sometime, and after some time they transferred CVKS. Our technicians transferred some services to that newer system, but it's not new anymore, and something broke, and I'm not very much informed of what exactly went away, because they are talking to us as we are not capable of understanding the technical details. But it is a thing that it's not easily, they can't easily get, and the problem are the data. I'm not sure whether they underestimated backing up the data, or what's the problem, because otherwise we could buy just another server and everything and just put the data there. But anyway, so it's good to have some backups. And if that a server, a web server, actually also, which is placed there for our personal web pages, and like keeping the information on all my courses on that web server within my personal web page, or it doesn't work. I gave you a different kind of. I actually copied my whole website, which is very simple because it's pure HTML, to another location where you can access it. So you receive the link. So you have all the information available. So when the things start working again, you can get back to official website. But it's good to have some backups, as we learned from this example again, once more. So we can have a situation like this, that having an SMTP server represented programmatically as an object, of course. So there is some hardware, there is maybe some dedicated server, physically dedicated computer for this, whatever, but no, we're not interested in that. For us, when we deal with this, we set some properties or whatever, it's an object or a set of objects actually interconnected to each other, so that we can deal with this. So it's being set up during the initialization of this object. Some things then there have to be switched in that hardware and so on. It always happens like this with programming, of course. And what we want to do or have is that if an SMTP server fails, it should be replaced by another one. So this should be kind of automatically called. So you could imagine really like it's not really it's just some kind of a server. It's not. I'm not pretending that I'm dealing with SMTP server anyway. In anything. In any specific way, but it came out just as a possible example. So let's have of a server. So let's have it programmed like this. It just can be connected. There is not everything there, it's just what we need there. What we need is to know whether this works or not. And this is being indicated by this Boolean attribute connected field in Java parlance. The SMTP server is being constructed by its constructor, and when it's being constructed, it becomes connected if everything goes well. Whether everything goes well depends, well, I could introduce some random numbers here or something like that. It depends on whether you could really make hardware set everything to what you needed, and you would get eventually that information. But for the sake of simplicity, I'm just simulating this by these two parameters. And it's really stupid, so I just when these two parameters are equal, I say that everything is fine and it's connected. It's just for the sake of enabling a particular two kinds of situations. And when one more thing is there, that I can check whether the server is connected. Nothing special. So I want to introduce a backup server. So we have this situation here. So I create a new server, and then I provide this information. And when I initiate this server, it might break. It might, I might get the information that it failed. It doesn't work. I don't want to be this like that, and I prepared another one like this. It's just another kind of the same server, but it actually does some things differently because it will run on a different, it will connect to different hardware or whatever. It's a different thing, different machine, different thing. To simulate this, well, I make this always work, so I ignore the parameters. Actually, not ignore the parameters, but I provide always equal parameters to the general. This is a specific one to the general SMTP server I actually derived this server from. No big deal. And I can also test whether this is connected. So the question is, well, I have this another class, but I have these servers activated somehow, something like this in code. And here I have this SMTP server sometime, and I want to, when it fails, I want somehow to put there this another SMTP server. Maybe I should have shown you that I derived this server from the initial one. That's a part of the solution, a little bit. That's a trick. But anyway, even if you know this, so what could I do? I cannot really mess up with this code. There might be a lot of places like this or a lot of code like this, and I'm adding this backup capability on top of that. And maybe the reason is because I'm selling two kinds of systems, one with this backup capability, and the other one which is less expensive without it. What should I do in aspect-oriented programming to deal with this situation? Come on, you're not helping me in any way. By now, you must be comfortable with all this saying. The first thing, we have to capture this joint point. That's safe. You can say this always. That's the beginning of all the things. So this is the place, you can see it. No doubt we need to capture this. But then when we capture this, and what we need to do? One thing is to discover whether this works or not. If it works, it's fine, go further, let it go. But if it doesn't work, when we capture the joint point, you learn so far when we capture it, you can prevent it from being executed. You can execute it conditionally. You can execute it repeatedly. You can even transfer it to some other, put it away on some stack or queue or some structure wrapped up in an object, even that. But now the situation is a little bit different. This won't help because no matter how many times I execute this joint point, the SMTP server which is connected to this object is simply bad. It won't get better. It's dead. And the CVPKS is working on its replacement, and within a month it will be resolved, but it's too late. So we want to activate another one instead, and we have it. We have this another one. So we want to replace this. This is the creation of an object. The constructor call. Constructor actually does not really create an object, but it initializes it. But behind that, afterwards, the object is being created. So we want to put another object instead of this one here. that's the question. So this is maybe an idiomatic thing, idiomatic part that comes into play here. So you might say it's not a fair question then, this part of the question, but so far it was. And I received no clue from you, so I had to resolve it all on my own. But let me discover for you the rest. So the thing that you know, sure, you're capturing the construction. It's performed like this. Sure, you capture the arguments because you want to have control of them. And surprisingly, you need to try this. It's like a try, catch, block, something like this. So when here, this is in your hands. So you will try to do this. If it fails, you can do something else. So the trick is here for this else that you are going to do. And it's being implemented as a separate method, but I could have put it here directly. So let's look at this method. This method gets the SMTP server, gets the arguments, sees whether the server is connected. If it's not connected, if it's connected, it just returns that server object. And this server object is then being returned here. And it is being returned here. This is the situation that we had in a simpler example when I was modifying code, and the question was with this return statement and returning proceed eventually, because you're in a way doing this the same thing. And what do you do when there is a parameter, but there is a return value at the join point? So you can't in this situation here, you can't return nothing. You can return null. Yeah, you can return null as nothing. There's no object reference, but you can't say there's nothing really, no value. And you're returning in the end here is server. But if the things go bad, you want to return a different server. But this different server is an object of a different class. So this is SMTP server B that you instantiate and you return it. We could instantiate it here and try it again. But I'm not checking it, so that would be another thing. But we have no other option. So there is one kind of backup server here. And when we execute this, it will perform as expected. Like this. So if I put here, so this is server B reporting. So of course, if I put here one, server A will be reporting, nothing in the aspect will be activated. It's just simple server, not exactly server A, but the SMTP server, just the SMTP server, the generic one. So let's have one more look at this and this code. So this is the thing that this is this strange thing that I do. There's a kind of a bird that lays its eggs in the nests of some other birds, known as cuckoo. So this is called metaphorically cuckoo's egg. Sometimes patterns bear metaphoric eggs. Not maybe always a good way to go, because unless you know what's behind it, what's the story behind it, won't help you anyhow to get a clue what to do. Sometimes pattern names help you to come to the solution. It's sufficiently expressive. So what's happening here is this, that we have a class swapper. Actually, so we capture constructors like this, or constructor, and then it's essential because we need to exchange this object for another one. We use around device and return this different device. This is without any conditions and any unconditional returning. So for this example, so to make it simple, so in a way this is a complete code, but sometimes such examples also help you implement what you need. So you see that in my context I expanded this idea, and I checked up all the things that I needed, and then I created the object if I really needed it of this this different class. So in order to remember this pattern, you need to become aware of conflict of contradicting forces. And I express them like this. Instead of an object for one type, an object of another type is needed. So that's one side. But the original type must not be changed. So you cannot modify the original class. What to do? This whose egg. So that's roughly it. I have one more thing here. This is exchange class. Actually, maybe more generic example. This at this point we will return to these things sometime later, so not to overwhelm you with the information. And all other things, don't worry about these things that are also in the lecture. But one thing is there that I would like you to try even without my explanation. You will find an implementation of the observer pattern in an aspect-oriented way. We will get back to this in the next lecture with some maybe conceptual explanation and discussion, but the code there is simple enough for you to try it, simple enough for you to study it, so you can see how the pattern logic is being extracted and made in a way re-applicable. It's not fully generic. It might not be applicable to all contexts, but in a way it's kind of being pulled out from the application domain things as a separate mechanism and put away, in a sense, in one aspect that is kind of quite reapplicable. This is an interesting thing. One thing that is that we have aspect-oriented design patterns inherent to aspect orientation. The other thing is that we can re-implement object-oriented design patterns in an aspect-oriented way for the sake of their easier application. So well, not all things, not all things here we dealt with. There's another example that we can try that we did not deal with in this lecture, is aspect instantiation that I sometime managed to go through within this lecture, but because you did not help me with the problems that I presented to you, so I had to resolve them all on my own. It took me more time, so I did not manage to get to this instantiation. But don't worry about this. We will go through this in the next lecture. Any questions? Anything you would like quickly for me to explain before the time runs up? Okay, thank you for attending and enjoy the labs and enjoy Aspect Day. See you next week.